my name is Kiran, and this is Sarvesh, and we are from the Bing team. And we are a bunch of very passionate JavaScript developers. And when TypeScript came, we really loved it, and we pushed a great deal for its adoption across Bing and across all its properties. So here we are to give you a small presentation on what we did, what worked well, and also some of the tools that we have built to make the adoption easier. So here's my agenda for the talk is why we chose TypeScript, what is the current adoption rate and where we would like to be, and what is our plan to get there. How we integrated with the resource management system that we use in Bing for managing JavaScript and CSS files. And also we tried a stint with using AMD, but it didn't exactly work out the way we want for us, and we just want to put it out there to see how if you other guys have solved this problem. And finally, we want to present a tool where we just wrote a tool that converts JavaScript into TypeScript files to some extent. It basically speeds up and automates some of the manual tasks that you have to do when renaming JavaScript files to TypeScript files. So let's start with why we chose TypeScript in the first place. So this started actually when Bing Mobile was being onboarded to Bing Desktop. We were combining both these technologies. And Bing Mobile was a big user of Script Sharp. And so when we looked at their code base, we are a bunch of in the JavaScript team at Bing is very passionate about writing idiomatic JavaScript and functional JavaScript. But we couldn't really push back against Script Sharp because it did have a set of advantages in terms of IntelliSense and refactoring, and just the code organization was beautiful. So then we were looking for tools, and it is at that time that we found TypeScript that kind of seemed to satisfy both these criteria. We can write idiomatic JavaScript and still get the benefit of strongly typed contracts and interfaces. And so really it hit the bullseye for us, and we moved it. And the mobile team was the first team that moved their code from Script Sharp to TypeScript, and they all loved it. And as they loved it, we started pushing it towards other parts of Bing. So right now, as it is, we have 15% of our code base in JavaScript. This is basically all new development. Most of the new development that is happening, most new features and new areas are just using TypeScript right away, which is about 25K lines of JavaScript. And we still have 85% of our code base that we are wanting to get a push on and try to move towards TypeScript to get all those cool features. Some of the features in Bing that is Bing mobile experiences, or their iPhone browser app is fully powered by TypeScript. Bing Windows 8 app, some of the social features we have, like friends photos, and of course even parts of the search results page that you see on Bing right now. And our target is to hit 100% adoption, and we are looking at strategies and tools to enable us to do that within a reasonable time frame. So this is some of the best practices that we thought worked well for us at Bing. This is specific to the nature of the code base and nature of the problems that we try to solve in a web context. We are less of a rich web application. We are more of a, hey, we are a web page and we have all this JavaScript that provides enhanced functionality, right? We are less like Gmail and more like a search engine, and which you just go there, get your work done, and come out. So for us, we found that you can find the full list of practices we follow at that link. But we found that just using modules and interfaces works quite well for us rather than classes. Because if you see, most of our code is asynchronous, reactive, and it's a publish subscribe based, because all our code does is it loads on the page, listens for some events. When some event happens, reacts to it, and then fires another event, which some other part of the code listens to. And this kind of just singleton, reactive asynchronous code, just the modules work quite well for us. And also classes, the thing is when they are used right, they are great, but for our scenario, it often turned out people were using them very wrongly, wherever it's not necessary. And classes definitely generate more verbose code than just plain closures in JavaScript, which meant that for us, page weight, every byte that we have on the page affects our page load time. And we are very specific on the, like, it's very significant concern for us, even a few bytes of page weight and performance loss. And then, of course, coding to interfaces is the biggest benefit that we say we got from using TypeScript, and that's one of the things that we encourage across Bing. That's one practice. So in Bing, we use a system called Resource Management System. It basically provides a declarative interface to developers and see, hey, it manages both, the build time aspect of resource management, which is crunching and concatenating resources together, and also the rendering part, whether you want to inline a resource or whether you want to, reference it. And it also has some developer productivity features, like, for example, if you have a JavaScript file and you change it, you don't have to build anything. It automatically has a file watcher that listens to the changes and kicks off a partial build, and you can see your changes instantly. So we integrated TypeScript fully into this, so Bing developers, get all the benefits of this system while still using TypeScript. We use Node.js to invoke it because that's what we found the most versatile instead of relying on the IE engine. That worked well for us. The only thing though is when we have to invoke Node.js for every single file, our build suffered a lot, so batch compilation saved us. But even with batch compilation, we are finding that as we are moving more files, we are hitting that, oh god, the build times are increasing limit. So hopefully maybe the new versions of compiler will help us on this aspect. And so yeah, So I talked about resource management system briefly, and this is how the declarative interface of a resource management system looks like. It basically says, hey, there's a resource, and point that resource to these file paths, right? And for example, for Win8, we use a different implementation of Ajax history, and for normal browser experience, we use Ajax history. And so one thing we tried to do with AMD and TypeScript is have this level of dependency resolution. So which is basically saying, all my code should just say, I want ajax.history, import ajax.history, but at runtime be able to decide, oh, in this scenario, actually load ajax.pushState, and in this scenario, load ajax.history, right? We developed our own AMD loader, which took care of both the client-side and server-side AMD management. But some of the things that we ran into is modules and interfaces are not really compatible. For example, if I create an interface, I can't really enforce that the implementation of that interface, which is, if it's a module, I can't really enforce that it implements all of it. And then also, in just my code, if I just import to a d.ts file, it doesn't really work right now because, so if I'm writing AMD code and I'm importing an AMD module, I have to point to the actual TypeScript file and not to its declaration file, right? So.
No, that should not be the case. But we could take it offline, but you should be able to not touch your imports.
Okay.
And use the TS files. We'll pick up the TS file if that's the one we find. Otherwise, we'll look for the d.ts and grab that one.
d.ts. Okay, we'll follow up on that. Well, this experience was when we were using a slightly older version of TypeScript, so maybe things could have changed. I just that's for the introduction, and what Sarvesh wants to present is he has a tool that we recently did to move our code base from JavaScript to TypeScript at a scale. And so I'll hand this over to him.
Hi. As Kiran mentioned, we have around 1,500 files, JavaScript files in our code base. And contrary to most common websites, the way Bing is, we have one page and there are like 100 plus feature teams who have little features on that page, like a news answer, video answer, images answer, who all get onto the same page. So apart from just like developer productivity, which is a great advantage when you are using TypeScript, if even one single feature team has JavaScript, which results in a script error, the way script is injected onto the page, it cascades to every other script. Basically, script won't execute. And that shows up a lot in our performance, like the whole page rendering performance or user engagement. So there's a lot of ripple effect. So what we really want to do is get all of Bing with all the feature teams in different parts of the world to adopt TypeScript, and their major concern usually is that they don't have bandwidth or time to go and fix the problems. So what we tried to do was we converted one project manually. Like what we did was we didn't change the code because we don't own the code, but what we did was we went and said that, okay, whenever we see a TypeScript warning, we'll annotate it with any or something similar to get at least TypeScript to pass and then convert the file, because after this point we'll stop the bleeding. Any other warning in our build system is treated as error. So anytime a developer accidentally creates a global variable or writes some JavaScript accessing a variable that was not defined, which would eventually result in script error at runtime, TypeScript would stop them right there and they won't let you check in. So then after doing this one manual project, it was like tedious process. So then we looked at TypeScript compiler. It has access to all of AST. So whenever it is outputting errors, we took the location in the code base and had a wrapper around TypeScript compiler, which would go and fix that JavaScript file to be perfectly with 0 warnings compiled in TypeScript. So this is an example where let's say this is the file. It uses similar technique to Monaco, like it uses TypeScript.js in the compiler. As you're typing, like it'll do something there, like automatically compile it on the right. For example, in this particular case, I have a sample function with 2 inputs, but someone is calling with 1. So it does put a question mark there to say that, okay, it's an optional. But let's say if I do update it here, it'll remove that question mark because it can see that, okay, there's no error, so let's just use this JavaScript as it is. And it'll produce the version. So I can get into console in a bit. And so I have some examples here to quickly do this demo. Like this is argument mismatch. These are real problems that I saw in code base, but instead of showing you the whole code, I thought I'll just show you the bits of it. Like we had functions with no arguments and not using arguments inside, but people were passing in parameters. This could be legacy code, dead code, but we really want to identify this and fix this. So the plan is we will produce a version that is TypeScript compliant, so at least no one can in future add to this problem, and file a P1 bug for this to feature team. So they have around 2 weeks to 3 weeks time to fix this. So we'll get the problems fixed because TypeScript helps us identify, and in future we won't at least introduce more problems. Now, another example is, this is what I saw from our code base. Like someone had defined a variable error callbacks, but they forgot to use this right casing and it accidentally introduced a global variable. But so right now this TypeScript tells you that this is error callback, like this is a global variable. And we could file a bug, and if we fixed it, it would just compile fine on the right-hand side. So a more complicated example is this. This is our real code. Like this is the code that we use for in Bing for some of the social features. I mean, this is, I guess, 30K of code. That's fine. But in this, TypeScript automatically pops up that, okay, these are the variables that are global. And most of them are accidental, actually, 3 of them. And one is, so this is basically, we didn't know this. This is functionally correct code, but this is not crunched, which is a performance problem. Now, so the tool that we wrote around, this is a web interface, but what we did was we took a project, we converted, let's say, all the 50 files in this project, and then some heuristics that, okay, if a global variable is only repeating one time, it's most likely an accidental typo that you could fix as P0 or P1 right now, this is a problem. And if there is something that is repeated in 50 files, most likely it's a reference issue that could be fixed. But so this gives you a good insight from TypeScript into our current code base. And because I was trying to play with this and make it a little generic, so I took jQuery build and said that, okay, if it can actually fix jQuery. And it does. So in fact, I also tried WinJS UI, which is 1.6K of code as my test case, and it did convert WinJS UI into a valid TypeScript file too, also with a lot of, I think, 657 any fixes through the compiler. So in this particular case, it does show you all the errors that it found, and then eventually fixes it. And just to be sure that what I produced is actually valid, I just do a second pass with TypeScript compiler and say that, okay, no errors found. So it's not that we fixed, I thought it's a wrong fix, and we still have problems. So in this particular case, for Bing, now the goal here is that we accelerate the movement to TypeScript. So once we have all files in a TypeScript code base, then it's good for developers. They have a framework to write JavaScript. So far, they just use ad hoc, either Notepad or Visual Studio without any IntelliSense. And the second is, in production, we improve performance along with script errors. Like, if we reduce script errors, our user engagement would be much better. So yeah, that's what we did for Bing. If you have any questions, please feel free to ask any of us. And sure.
So
Do you need?
I'm curious what kind of mileage you got out of JSLint or JSHint before doing this work. To repeat the question I was asking, whether or not you tried JSLint or JSHint before this very interesting approach.
So we did try with JSCorp instead of JSLint. The problem is there we had to do a lot of decoration, but it was not maintainable. Like, there was no real advantage to developer to actually decorate your files to get Coffee Maker happy or JSCorp happy. With TypeScript, it's intuitive. Like, once you fix it, it actually helps you with JavaScript. Like, the experience of writing JavaScript is much better, and it's like inline type annotations and wherever it is necessary.
So to check my understanding, you are, after this conversion, are you checking in the new version, or is the conversion to TypeScript only temporary for error checking?
We are checking in this version. So from now on, every developer has to write in TypeScript files, so they cannot check more bugs in.
That makes a lot more sense then. Thank you.
We should just run this company wide. That's awesome. Another question? All right, well, that was great. Awesome.
Yeah,
Thank you.
Yes, that's amazing. Okay, Wolfram?
Cool. Hello, everyone. I'm Wolfram Schulte. I'm from the TSE team. We started a new team a year ago. And I worked in research for a long time. I always wanted to improve engineering systems. I tried that here and there. And then somebody said, OK, now make it real. And so the question is, who has ever had problems with their build system? Or who is happy with his existing build system? Yay! OK, so that's the motivation for my team. So let's see is whether we can actually improve our build systems, and not by inventing yet another XML derivation or something like that, by seeing is whether we can actually use languages. And we've seen that actually a lot. So in the build language, initially there was Make, and then we had ANT and MS build. And meanwhile, lots of people using DSLs, but that might not actually be the right thing. It might be the right thing if you use a DSL that's targeted for it. And so we used TypeScript, but instead of adding more and more features, we reduced it so that we have complete control and know what goes on. And I'll show what that means. So reliability. For build systems, the most important is really reliable dependency tracking. And I'll show you how that works in TypeScript. Ultimately, you want to, in some sense, if you have big build systems, so we're currently working with a SQL build system that has 5,000 directories with build description files. So you have to build abstractions in order to manage that reasonably well. With the language, you have some opportunities to do that. And so normally you look at functions and modules, but we really want to move it forward to think about versions, and we use visibility for those things. While build systems are not only often not reliable, but they're also really slow. So our big build systems typically take hours to compile. I don't know where DevDiff is right now, but that's probably plenty of hours. SQL is at 2 hours right now. But there's no reason that we have to wait for 2 hours if we would actually look at the build systems differently. And so what we want to make sure is that we always build only what is really changed, and that you never wait longer than the longest critical path in your build, which for SQL is something like 12 minutes. And so we are waiting 2 hours. So why is that? And ultimately, you want to reuse the work of others in your build system, right? Your colleague is working on the same code base as you, and 90% of his files are the same as yours. Why are we building again and again? OK, so we thought, well, we need in some sense a precise description language for writing builds. Let's see what we came up with. And before doing that, I'll show you why we actually want to have a different language than, for example, MS Build. So here's a very simple project where, in some sense, you have 3 dependencies. You start with a source file. Oh, that should probably be a.cs, and you end up with c.dll. So what happens in MS Build, you make it a project system, nice. You can schedule it really, really fast. And suppose this is 1 unit, you need 3 units to schedule it. Now, the nice thing that people in task-based build language thought about, oh, let's give a user a simple hook to say, oh, after you build CSC, maybe you want to run fxcop. So you add fxcop, and it's still in the same project. But now what happened is that in some sense, you lost a little bit controllability of the scheduler. You only see really these dependencies. You don't see those. And as a consequence, MS Build schedules is like that. In some sense, in the worst possible way, you always have to wait for fxcop to finish before you do the next CSC. What you really want to do is actually have different mechanisms for schedulability, for dependencies, and for name scoping. So take this away. So think about this as just being a module and have just those dependencies. You can schedule it differently. And you see that in some sense you can be much, much faster than MS Build on the same hardware doing the same jobs. Okay, so what is now CloudMake? We thought, well, it's a nice language that has in particular structural types with which we can in some sense describe the layout of our builds without providing any typing. So let's take in some sense TypeScript, but prune it down so that we really understand all the dependencies. And then make it easy to extend so that you can write your own, you can easily integrate your own parser generator, whatever special purpose tool you have, or Perl script. And let's make it so that it can work standalone, even as a deployment workflow engine, where you don't have to install anything. We use it for, in some sense, our environment, which is called Cloud Dev. Okay, let's write the simple build script. That's it. It's main. Let's call it CSC and plug in some resources, sources here. And that's it. And you have to say, oh, somewhere, where do your tools come from? They come from tools, standard tools. That gives a name scope, and in this name scope, you'll find CSC and an interface definition for the arguments for CSC. That's it. So what you see is all our dependencies are described as simple functions. There are input artifacts, like sources. There's a tool. There's an output. That's it. So if you want to have 2 calls to TSC, you have, in some sense, 2 declarations where you can use one for the other. So let's do that. Build a little bigger system. Let's suppose that we want to build something for Office, Word, here the speller. And let's first define an editing surface. Okay, so now our arguments for CSC become a little bit bigger, assembly name and output type. There are sources in here, but there are also references. The good news is everything is typed. We know that this must be a DLL, from which we then select, in some sense, the DLL. And so these are references to other build artifacts, which are somewhere in this reference path, somewhere have to be defined, right? Just in a normal programming language. Okay, and what you see is everything is typed, but no type annotations is needed. I don't have to show you Visual Studio. You can click on it and you get to the definition of Microsoft Office Word.speller if you want to see it, or to the definition of CSC if you want to see it. So how does that help building bigger systems? Sometimes you want to build spellers for lots of different languages. Turns out that they are relatively simply to construct because you have different CS jobs that you have to call. And so you simply say, okay, there's my core speller, and I want to build my English and my Dutch speller. And in order to build those, I call a function build language, which happens to call another CSC. So everything just works right out of the box. There's no problems here. And as you see, is what really happens underneath the covers is that there are artifacts and there are tools. Tools produce artifacts, which are consumed by tools. And so you get exactly all the dependencies that you want. So now the question is, how do you define a tool? So here is, in some sense, a very simplified version of CSC. We know that it has 25 arguments. Here it's only 3. So whenever you describe a tool, we use an interface to say what are all the options, the arguments. And then we, in some sense, have a definition. And in this definition, there's one magic function, and this is exec. Exec is like shell execute that you also have in .NET or that you have in Windows. And that's, in some sense, the tool that's being executed. And here we call, in some sense, CSC with the proper arguments and dependencies. Right? So in some sense, we grab the arguments, and certain arguments actually become dependencies, and that's what we'll track. Okay. So then, what's in it and what's not in CloudMake? CloudMake is a subset, as I said. So it turns out we wanted to use Visual Studio and everything as much as possible. So the primitive types and operations are all the same, whether they are nice or not. We just said, okay, it's the same. Arrays and objects are supported, but there are no side-effecting operations. You can't set the length of an array. You can concatenate elements to an array, resulting in a new array, exactly as Java said, but you can't do push, because that's a side effect. All variables are single assignment only, which means is that these artifacts that we produce are absolutely stable. They will not go away. They will not be overwritten. There's no misunderstanding what a particular artifact is. And since we didn't want to have side-effecting operations, there are no classes, and we could add overloading. Currently, it's not being supported. So what is special in CloudMake is only two little things. One is we have special support for parse. Not really special. We just hijacked the single quotes. And that's, in some sense, if you write something in a single quote, as we have seen, a.cs, then it implicitly gets, in some sense, the location of that file where a.cs was referenced, so that you have the full path available. And we have then some operations that making sure that you can't merge paths with strings unless you use an explicit operator like path combine. And we have a change in the semantics. Our variable initializations are lazy. In TypeScript, you execute them in some sense in the order as they appear. But since we only evaluate variables once and there are no assignment, we can in some sense do a much smarter way and do it all demand-driven. Okay, so we initially took the Chakra engine, and then we ran into various problems, and also doing the work then in the existing TypeScript compiler was difficult. And CloudDev runs is in some sense a service for build in the cloud, and we didn't want to put another engine inside and another garbage collector inside. And since we have this special tiny little subset, we said is why don't we write the interpreter directly in .NET? And that's what we did. So, and instead of translating that in a different representation, we use the abstract syntax tree as is and have a type-tagged representation. And since there's not much computation going on in a build, it's relatively simple, right? You just call in some sense, you build a dependency graph and you schedule it. You don't need, in some sense, high-performance execution of loops. What you need is really rapid evaluation of the build graph so that you know what you're rebuilding. Okay, so we do this. We have, in some sense, when we evaluate, we first build a schedule, and then we schedule, and the schedule can then actually be run distributed as well. So let me see what the performance is that we got out of the system as of today. So when we evaluate CloudMake programs, compared to just compiling it in TypeScript. So evaluation means we have the DAG. That's currently 7 times faster than compiling TypeScript because it's native, right? We don't go through the JavaScript hoops, which is very reasonable for other scenarios, but not for ours. When we run MS build compared to just CM, and it's exactly the same thing, and you ask sequential execution, of course, then everything happens after another. You can't be faster unless you do a little bit magic with resolving files, so we're a little bit faster. You run multi-core. Since MS build doesn't scale so well and doesn't schedule so well, you can easily outrun MS build. If you do incremental, since we're using fingerprinting and we only do incremental computation bottom up and not over the whole project graph. We are sometimes up to 25 times faster. And we can run distributed. And there we guarantee that the worst case execution time is the time of the length of the duration of the critical path. So these are great numbers, but unfortunately you can't use it yet, but I hope that we can give it to more people within the next couple of months. So where are we? Yes, we are in the SQL build lab and currently running side by side, but not with these performance numbers, because there we only have a MS build version that we parallelized. We are currently looking into using CloudMake or TypeScript in order to describe multi-flavored and multi-versioned builds. So how do you put versioning in addition with staying completely in the TypeScript world? There's some nice ideas. One of the things is we have just seen a great tool converting JavaScript to TypeScript. Can we take an arbitrary build.exe, so a make description or an MS build description, and generate a TypeScript or CloudMake description out of it? And so we have actually the first prototype from it working where we actually take a trace. So what's very different in build systems is that you don't run 1,000 different programs. You only run one program in 6 configurations: checked, unchecked, AMD 64, x86. So in some sense, if you have only a very small number of traces, you might be able to synthesize a program from it. So we try that. We built you a simple exe so that you can use it within the next 2 months. And we would love to get your feedback and see whether this all makes sense. Thanks so much.
Awesome. So it's actually interesting because we actually do something similar. We use TypeScript to do both our resource string tables and our config setting files. I don't know if anyone else is doing the same thing, but we find it's really nice to get basically strongly typed all the way out through to our string tables and our config settings and so forth like that. It's a really great idea. Any questions, real quick? Randy is the designated question asker.
I'm so curious. So, considering that Rick and I spend most of our time crying about unreliable builds, this is really dear to my heart and very interesting work. So, I'm curious, what you have to say about the relation of this to some systems such as BuildCop and DBB, which, as I understand, are using ETW events to make sure that you don't do stupid things like ours does, such as write the same file twice, or read something and then write it again, and all of these things. You mentioned, or even systems like TUP, which try to know what has changed rather than traversing the entire graph. You mentioned fingerprinting and going up the tree, so it sounds like you probably, I'll just hand it to you.
I think all great questions. So BuildCop is in my team. We use it as an onboarding tool. So if your MS build based project is BuildCop clean, we can onboard you on Cloud Dev or with an MS build based distributed scheduler and our own caching story. So this is in some sense how we want to help people migrate to a new build system. CloudMake is the next step above it. And some groups might never want to go there, so this is in some sense speculation whether this will succeed. There was the mention of different traversals for finding, for doing incremental builds. And so if you actually know what files have changed, then you can do just bottom-up traversal, and you don't have to, in some sense, inspect the whole world again. And that's what we actually do. We are connected in Cloud Dev to Source Depot and TFS, and so there we get, in some sense, the change set, and therefore we know exactly which files have changed. And a funny number in SQL, over the last 3 years, in 80% of all check-ins, not a single build specification was changed. So that means it's only files changed. That means the build graph was always the same, and we are computing it again and again. So we want to get rid of this waste and be a little bit faster.
And so you say you were, you said something about fingerprinting and I believe
Yes.
then caching results for a long time as far as...
Yes, so we cache in some sense not per developer, but for all developers at the same time, so that you can actually get in some sense the build results from your colleague irrespective. And we do that by content-based hashing and not by timestamp and file location.
Well, in that case, that certainly answers all of my questions and sounds truly excellent and, in fact, reminiscent of some of the ridiculously awesome build numbers I've seen from some Google presentations using similar techniques.
Yes. So that is an inspiration for us.
So you all met me at the beginning. I'm Ron. I am a senior engineer over in Visual Studio Cloud Services. And I've been playing around with TypeScript just to see what I can get it to do. I've also been following, I'm not sure if anyone else has, the current direction of ES6 as they're adopting new technologies and new features. And I've always found some of these new features would be really interesting and nice to be able to use today. And having a cross-compiler or transpiler like TypeScript and the ability to fork it and make changes to it gives me kind of the opportunity to play around with some of these language features before they're even, in some cases, fully implemented by various browsers. So assuming this works. All right. I'm going to talk about 4 things that I've already seen that some people have some interest in. One is decorators, based on Python-style decorators, if anyone's ever worked with Python. Another is iterators and for-of, which is a feature that's part of planned for ES6, as well as generators. And I've seen a lot of people talk about async and await, and I've played around with adding async and await support. Most of this is available via a fork on Codeplex today based on 0.8.3. I'm about 30% of the way in moving all this to working on 0.9.0 as well. For anyone not familiar with decorators, the basic concept is that you can supply a function that actually mutates or does basically something with another function. In this case, I've got a function over here on the right called log, and its expectation is it will take in a function, and then I can either do some type of analysis on it, store some information about it, or completely replace it. And in this case, I'm going to return another function that, when executed, logs that I made that function call and then executes the inner function. What this allows me to do is then compose this by defining the decorator as almost a modifier to that function call. And this works or looks somewhat similar to attributes in a language like C#. It has some similar concepts, but it's actually much more powerful because in addition to being able to track and store information about one of these functions, you can completely replace it, you can augment and make changes to it, which allows for a much more dynamic range of possibilities. In this case, I've got a function that can be logged. Here's an example of a class that could support a mixin. Not shown would be the mbar class, but in this case, the mixin would take in the object, iterate through each of its properties and assign it, and only having to have an interface to describe what it actually looks like. Another example here is a class that actually takes in a decorator on a method. Now, the way that I've built decorators for some of these examples is to decorate classes, methods, getters, and setters, as well as functions. Some of the examples of what this might actually look like. If you look at something like Ember.js, which is a pretty powerful system for dealing with models and view models and interactions, the way that they define things in Ember in ES5 and earlier type development is around creating functions and doing these types of extensions off of the function object. Once you move to a class syntax, you actually don't have that capability anymore. So the example I have on the right would be an example of the same type of thing using decorators on a class, where in this case, I might have a decorator on a field, which can, behind the scenes, turn into some things that execution that can happen at declaration time. So knowing about that field when the type is actually built, as well as when the type is constructed, allowing you to mutate what the value that gets stored into that field is. And in the case of the bottom here, we have a property. This actually gets attached to the getter function as it's executed. You can replace that function and then do things like set up notifications that when this changes, notify other objects that are participating in observation that the property has changed, or when those properties have changed, that this one should be updated as well. Another example of decorators is in a unit test framework. This is an example from a test framework called TypeUnit, where you can define tests, in this case, very similar to if you've used XUnit or MSTest. By defining a class that contains your test fixtures, you can actually annotate which ones of these methods you actually want to use as a test-based method. Additional annotations for things like how long should the test execute asynchronously? Does the test actually take in data and should be executed multiple times in a theory-like test? And another example here is asynchronous testing can be hard because of the fact that once you hit a callback using setImmediate or an event or anything, you're now outside of the test framework and you've lost the scope of what you were actually testing, so assertions could be lost and raised to the browser. In this case, this is a decorator that replaces that function with or wraps that function rather with one that injects it back into the test framework. So there's a lot of power that you can get out of decorators, more over and above what you would get just writing functions and having to write all these things inline in code. Now the way the decorators actually work is that they take whatever function you're calling and then immediately after their definition rewrite them by executing a function call. So you could get this exact same bit of code by moving the test decorator down to the bottom and saying promise fixture prototype compute async equals test with promise fixture prototype compute async as the single parameter, but you would lose a lot of the context that you get here. If I have time afterwards, if anyone's interested, I can show you some of the additional things that go along with decorators here as well, but there's a lot of context that it can pull in. I am trying to go pretty quick through these because I know there's a little time. Yeah. Skipping the builds here. Oh, I do want to go back to the second. If anyone is interested in looking at TypeUnit, it is up on CodeBox, but it does require that the decorators fork to actually be able to execute. Another feature that's available in ES6, or will be available in ES6, it's currently only supported, although not to spec in Firefox, is a concept called iterators and generators. The concept of an iterator is it's an object that has a method called next that either returns a value or throws an exception. Although that has changed as of May for ES6. What you get with the value of an iterator, though, and this is kind of an example of a simple one, is as each value comes out of it, I can use something called for_of to get each one of the values that gets returned. You can also execute that function, get the object, and it's similar to a IEnumerator in a language like C#. So for_of is similar to for_in, except instead of enumerating over property names, it enumerates over whatever you've defined to be the iterator for that class. An example here for a class would be there's this prefix, an asterisk that you have to put on there. The main reason that that exists is because of the fact that the yield keyword is not reserved in JavaScript, so they have to have a way to say that I'm opting in to yield as a keyword. They do that with the asterisk, so that same syntax carries over to the class and allows you to define iterators that can, or in reality these are generators, to return values and return back into that function at the place where you yielded the value. Now, because of the fact that TypeScript doesn't support symbols and ES5 doesn't support symbols, and it's even kind of unclear as to how that's going to be supported in ES6, to support iteration on any object where you could use a for_of, I'm using a special keyword here that's __ iterator to simulate the iterator property that's defined in the ES6 specification. And all this basically says is if I'm passed a value here that has one of these methods on it, this method gets executed. It's similar to getEnumerator on an IEnumerable in C#. The way that I've built the generators functionality is rather than adding a lot of boilerplate code to each of the TS files that needs to use it, Instead, all of the code that's necessary to make this work, like the stop iteration exception that gets, not exception, the stop iteration that gets thrown that says the iteration is complete, those are all actually part of a library file that needs to be imported. And this is similar to how language integrated query needs or in the past needed to have a special assembly added to actually support it, or the namespace reference to actually be able to use any of the language integrated query features. So in this instance, you don't actually have to ship any of the generator's logic if you don't need it. Your code files don't get polluted with a lot of boilerplate code. And you can pull it in via an AMD reference or a script reference when it's needed. Now, the downside of iterators and generators is that it's not supported in ES5. The only way to make this work is actually rewriting, which is, again, one of the major reasons why it's not something that would be considered for TypeScript 1.0. And I'm not going to show it here, but if you want to see how ugly that looks to generate the state machine that's used for these, it's not very pretty to look at, unfortunately. I do minimize it a little bit by trying to support the source map capability, using source maps. The problem with source maps is that because there's a lot of code that happens behind the scenes, there's a lot of F11 stepping through to get to the next actual line in the execution. Iterators, though, are pretty powerful. Generators are pretty powerful and use more than just the iterator sense. Iterators or enumerators in C# just return one value, and then they return the next value, and that's all they really can do. Generators, though, have the ability to send and receive data back and forth between the suspended function call and the call site. So I can actually send data back and forth. In this case, yield isn't a statement, it's actually an expression. So when you work with a generator, you go beyond having a next function to actually having next, send, and another one called throw that allows you to actually return to that specific point where the yield has paused and have some type of completion, whether it's an exception completion that actually throws an exception inside of that method, as if an exception was thrown where the yield is, or the return value that becomes the value of the expression. So this allows you to actually send data back and forth. In this case, when this generator is called or created, the first call, the next, comes through, yields the first value, and then I send a new value in, which continues execution, then I yield the next value. And this is where we could get that same capability that you might see in a language like C# with async and await, because all that's doing is performing some execution, then handing off the wait, the need to wait to another mechanism, which then comes back into the function call at that point and continues execution. So building async and await on top of generators is actually relatively simple. There's no real rewriting that needs to happen compared to what actually needs to be done to get generators to work in a pre-ES6 language. I'll skip past this a little bit here. And the last thing that I think a lot of people are interested in is async and await. Now, async and await here are basically sugar on top of function star and yield. In this case, async is only recognized as a keyword if it's immediately followed by the word function, or if it's immediately followed by get, set, or an identifier when inside of a class. But it works pretty much the same way as function star. It allows you to use the await keyword, which again says whatever value that's coming here. In this case, it looks for if it's something called a thenable, which is a promise or a future. Any object that supports the promise A plus or promise A then method, which takes in a callback and an error handler callback. So in this case, it actually wraps all that behind the scenes and returns whatever value completes when it completes, so you can continue. So this allows you to write more complicated asynchronous code without having to delve into the complexity of the asynchronicity or deal with lots of .then this, then .then, or even more complicated scenarios where you actually need to do asynchronous polling and things like that. Having await actually makes this easy because it hides a lot of that complexity behind the scenes, but allows you to write very powerful code. And again, I'm going to skip past these for time. Just what I've been putting together, the TypeScript support for decorators, generators, async and await, and for of. I built into a fork that's on CodePlex. If the decks are available, the links will be in there. They're kind of too long to actually be able to grok on the PowerPoint. What is supported right now is decorators on functions, classes, methods, getters, and setters. Iterators and generators based on the ES5 spec, ES6 spec before it was last updated in May. May actually in May they made some changes that change how the generator objects return values to get rid of throwing a object. And it supports async and await. There is VS Editor support, so I did work with setting up or updating the language service so you actually get proper syntax highlighting in Visual Studio, that when you're hit F12 on a decorator, it'll go to the actual source location where it was defined. There's no support right now for decorating fields. I do have a plan to support it, and I'm also working on a new version that supports 090 that supports the same things, but also the new capabilities for object literals that are defined in ES6 and being added to TypeScript. It'll support iterators and generators based on the new mechanism that's in the May version of the ES6 specification. Async and await, I might also look at array and object destructuring. I have another fork that actually supports that, but I'm not going to get into that now. And possibly generator and array comprehensions, which I won't delve into if you're not familiar with it. But again, both of those are actually, the progress for both of those are actually up on forks on CodePlex today with the links provided. So, awesome.
That's really cool stuff. So we will start the around the room questions.
I guess I want to understand what happens with the async await when you have an error. Do you you just throw the error, and what's?
It works pretty much similar to how async and await work in C#. The idea is behind the scenes it's using a promise or a future, which is an object that represents either a successful completion state with a possible value or an exceptional state. And whenever you chain with the then method onto it, you either get the success callback or the failure callback. In this case, I'll go back to the example here. In this case, await works similar to yield in that I'm going to take whatever value is here and then I'm going to return it to some other background function that's actually executing and chaining these continuations. When the chained continuation occurs or is executed, it's going to be executed as either a success, which means the value will be returned, or an exception, which means that when this returns, it'll actually throw an exception at this point. So you could put try catch around this and catch the exception that happens asynchronously. Now the tricky part with JavaScript, and it's actually kind of complicated in C# as well, is the fact that if you're dealing with promises, those exceptions, if you don't explicitly do something with the exception, they can just be swallowed and lost, and you don't have any insight into them. In C#, when they added async and await, if you specify async void, that means that do this thing asynchronously, but if there's an exception, raise it to the application domain so that it'll still bring down the application because it's unhandled. In the browser, what I do is actually pay attention to the fact that you specified void as your return type, and I change the type of logic that's emitted here to actually chain at the end of the continuation that I need to throw this in another callback to basically raise window on error. If you do an async void, then it does that. If you do an async, that's anything that has a then method, then it assumes you're going to do something with that value when you're done with it.
So there's the new style promises, which just have a then, and then the old style, which have a then and error. Do you know the difference between the two?
Sorry, the old style, which?
Well, I have my cover. So the old style promises have like an on then and like an on error handler. So you have like a different handler for error and then.
Yeah, the then continuations, I don't know if I should use a whiteboard or something. The way that, so this is all designed around the promise A+.
Yeah, so
which
it's the
specifies
A+, it's
then,
the new
which
style.
takes 2 callbacks. And there's a couple things you could do to deviate from that. In the case of most promise A+ libraries, then has a return value that is another promise that is the result of whatever executes in that function. Languages like jQuery deferreds don't actually return a chained continuation, they return the original one.
Right.
But it still works with that because it doesn't do anything with the return value. It just listens to the success or failure completion of the then.
Okay, well that's what I was getting at, is what success or failure. That's what I was saying.
And this is designed to work with WinJS promises. It's designed to work with any promise A+ library like Q or RSVP. I have a library that I've been putting together that's a polyfill for DOM futures that is designed to work with that as well, because they're all basically following the same concepts. And let me go to here. One of the things that the generator's TS file, which has most of the logic for this, it has is a couple interfaces that define what that contract looks like. So you can plug in libraries that might not actually support the .then continuations. Also, it allows you to replace, there's a very lightweight future or promise API in there that's about 50 lines of code that just supports resolve and reject continuations and guarantees that whatever you do gets executed in the next turn of the event loop. So the default one's pretty simple. It doesn't support sending progress notifications or cancellation or any really advanced things you might be able to do with promises. But you can actually replace this by replacing the function value or the property for defer to something else that returns something that looks like this and has something that looks like that. And as long as it follows that contract, then it'll actually be able to chain those continuations for async and await. Now what actually is broken is in await3, the result of await is any, because I can't type the result. What I'm working on for 090 will actually use the result if it's typed from the thenable. So if then has then of u and the resolve has a u value, or then of t rather, then I'll know what that
So
t value
thenable
is.
will be a generic, basically.
Yeah.
Yeah. Awesome. Any other questions? Questions? Oh.
Just was wondering, like, what a typical application that you've used some of this infrastructure in would be.
Well, one of the examples that I've been working with right now actually is similar to this. I'm building an application today that's leveraging it's single-page applications. It's a fully asynchronous system built on command query responsibility segregation. So it's designed to be fully asynchronous from the top of the stack all the way to the bottom of the stack. And it's all heavily based in JavaScript on the client side, which means that we can do a lot of things asynchronously. Now, whether or not we actually use this in production is an open question because, again, it's a fork. It's not supported, but we've prototyped a little bit with it. And one of the examples is actually going out to make a JSON P call out to Azure ACS to go and get identity providers and bring that data back. Another example is an asynchronous call that's going to make a request to send a command to our servers, and then we want to poll asynchronously for the result. And then when that result completes, complete the task or the promise to return the value. And that allows us to write some very succinct and very clear code in our applications and our view models without actually having to write a lot of then continuations or having to deal with XML HTTP requests and attaching to events or any of that complexity. So it hides a lot of that complexity. This actually is an example using, it's kind of a mixed example that's using the futures, the DOM futures polyfill that also I added an HTTP client that looks similar to the Web API HTTP client, but it's designed to be basically XML HTTP request, but fully asynchronous.
I would also add that in Node apps, your database is often on another box, so you wind up with these really long chaining kind of closures where you're doing this and then you're waiting for that. Exactly, and these things get nasty in a hurry, so like async and await would be awesome for cleaning up that code.
Our entire middle tier is already async await.
Right.
It's coordinating data across multiple backend services.
Ron mentioned this a couple of times in passing, the DOM futures thing, which he has a polyfill for there. The DOM itself is actually now in the standards bodies introducing the use of promises in the DOM directly. And so if that continues with the momentum it's had over the last several months, then we will probably see new APIs in the web platform introduce promises as a primary means instead of callback-based APIs.
Are they using them for the background worker thread things that they?
I don't know specifically about that, but they've started. They don't. So not any existing APIs yet, but some of the new APIs that are coming up, like web crypto and things like that. They're looking at them, and they're considering retrofitting them. So, for instance, this get JSON async. There's work being done on a fetch API in the platform, which would be a lower level version of XHR that would be futures based. So all of the investments at the language level on top of promises are sort of potentially very high leverage things that can sit on top of a lot of different platform technology.
Web Workers builds off of window post message, so it's already kind of locked into this callback method.
It's not very convenient.
No. Well, it's convenient if you're used to standard JavaScript closures.
So I think everything you showed was absolutely amazing. I hope we can take advantage of this as soon as possible. I had just a tiny little question about that sidebar, which was the await autolifts non-thenable values. Could you just explain that to somebody not aware of this issue or what's going on?
So the
there?
issue is that, let's say that we have something that might be an any, or I have a value that I don't know if it's a promise. This is something that's not necessarily an issue when you look at a language like C#, where, again, everything is statically typed, and you can know exactly what you've got when you're making these calls. And because of the fact that in the futures or promises or whatever they're going to end up actually calling it, APIs that are being proposed for DOM and for ES next, there are a lot of things that you can't really be sure whether or not what you're going to get is actually a future or is it a real value. So this is more like it makes whatever that value is, it's transparent as to whether or not it's actually a promise or a real value. So in this case, if you said await and put in a string, so if you put await and then a string literal, you'd get that value back, but you would get it back in a later turn. You could theoretically replace the promise system with one that says, hey, this isn't actually a promise, so I'm just going to return it instead. But the way that this is designed is whether or not you get back a promise or not, it'll still await it. And if it's a literal type, it should act, or a non-thenable type, it should be the actual value, as if await didn't even exist.
So for the plans for futures, with regards to typehub, is typehub still going to report a future as object, or is it going to report it as something new?
Well, futures, it's
Normal JavaScript.
So it's just going to say it's object.
yeah, it's not like fully transparent like a language like
it's interesting
E
because, like, you know, we've added methods which are like is promise, right, and stuff. Which they look for methods off of the object to try to basically reason, does it have a then, and so forth, right?
Promise today is a duck type contract.
Right.
So any of these things are compatible with that duck type contract, but they also are a specific implementation of that.
Yeah. Now, DOM Futures is actually trying to specify, or there's some discussion whether or not they want to take things that have a callable then method and make them look like promises, but there are libraries out there that actually break that aren't promises that could have a value that could be returned. So there is the duck typing side, which is what this does currently. There's also if DOM Futures becomes a standard, then it might be that one of the things there is a feature called future.resolve, which takes in a value, and if it is a DOM future, it'll resolve it. If it is not, it won't. And then future.from, I can't remember if they're back and forth between from or of, which will take whatever you've got, and if it has a callable then it turns it into one. So you can then interoperate with WinJS, jQuery, RSVP, jQuery, I already said that, RSVP, any of these languages to actually get, libraries to actually get a promise value regardless of what kind of promise it is and get it into a single known type.
That's awesome.
This is probably my C sharpness coming through a little bit too much, but in task parallel library, if you return a result before you've actually scheduled it, then there's no real cost associated with having an asynchronous task there. You said something about if you returned a string with an await, it would come back on the next cycle. Is that?
That's just because right now the implementation is naive. It doesn't try to say this is a literal, do something with, or this is a real value, try to do something with it. It's also because there's been a lot of discussion on the ES Discuss for ES6 that says they don't really want to provide that. They want to guarantee that it's always executed in a later turn. I know there's good reasons for that on one side or the other, but a lot of it is to make sure that you're not blocking, to make sure that you're not saying, all right, then to get the value, and then I've got the actual value, and then I continue execution.
Well, I was going to say something that's happened in our code is quite often it's like, oh, well, we're calling something that's marked as asynchronous, but it's actually going to do a cache lookup, and if there's a cache miss, then it has to go off box and get something. And so in that case, you want it to be as fast as possible, but it might be asynchronous, right? And so that's why I was curious about your answer to that, because I think that model is actually kind of when you're dealing with caches, that's kind of a common pattern that we've run into.
Well, with promises themselves, if you resolve them before you return the promise, it will happen synchronously, whatever. Yes.
Well, that's in tasks in C#, yes. The way that it depends on which language you're looking at.
In jQuery, the deferred.
Yeah,
exactly. But like jQuery deferred, basically.
Basically, however I handle await is however it is specified in defer. And right now, it's just a implementation that always guarantees that whatever callbacks happen in a later turn. because it's less code and it actually fits in a smaller library than having to do the, okay, is this real? If it's not real, or is this denable? If it's denable, chain it. And if it's not, then just return it and don't execute synchronously and just to make things smaller. But again, it depends on the library. I mean, you look at C#'s async and await, it will try to run synchronously as much as possible. So the expectation is that it'll run synchronously until the first actual asynchronous thing happens. So even if all your things are async, but you use task completion source and return the value immediately, then it's actually going to run the whole thing synchronously. It just looks like it might be asynchronous. But again, that's all based on whatever promise framework you use or whatever futures framework you use, that's what it's going to do. It doesn't do anything behind the scenes to guarantee one way or the other. Because I can't know whether that value exists because I don't know what that library you're going to put in there is.
So Luke, when is this going to be adopted?
When is async and await mine?
No,
yeah.
Well, all of it, none of it before 1.0, and I think all of it is on the table post 1.0.
It looks like a really elegant progression to the language. It's really nice.
Yeah, I've already written and given to Luke an entire spec addendum on the on decorators at the very least. And I'm willing to bet that async and await aren't going to happen until ES6 unless they want to bite the bullet and deal with having a really massive, ugly generated state machine inside of the JavaScript.
Well, did you say that the source maps with the generated stuff was a little awkward? You were having to press F11 repeatedly?
Yeah, and I actually brought that up to the F11 or the IE team around the F11 tools about the fact that this might also be a deficiency either in source map or the TypeScript implementation of source maps, but I can't really say, okay, I want to execute from here to here without stepping. Yeah. And I'd love to be able to do that because then I could skip through a lot of the state machine type functionality to get to that point.
That's exactly the behavior I'd expect. So have you tried in Chrome for comparison?
I have done Chrome. Chrome's the only thing really that supports source map stepping, and yeah, I've done debugging in it.
Do the right thing in Chrome?
No, it's still, you hit F11. You'll see the same thing today if you do a spread, I'm sorry, a rest parameter on your function, in which case, because the fact that TypeScript today uses a for loop to fill out an array object, when you have one of those, you're beginning of your method, you're going to hit F11, 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 F11 until it finally gets through all the arguments and continues. Yeah. So it's the same type of issue. Even though it's rewritten to look nicer, you're still having to step through all those same individual execution steps.
It's confusing in Chrome. It's confusing in Chrome at first until you figure out what it's doing. Right? Yeah. You're like, why won't it respond to the F11?
Right. That's just a missing debugger feature both in Chrome.
It's actually also missing in the source map format. Really? And that's something we've recommended that they extend the source map.
You need to be able to go to the source map and say, I want to, say, step through these, just like debugger step through in C#. I'm going to go to C# because that's my core language. But
the source map format is generally only about 1-to-1 correspondence between one expression to another, surprising. And not many to one or one to.
If I recall correctly, it was primarily designed around dealing with crunchers that were going to minify your JavaScript and give you that correlation so that you can see what it actually looked like, even though it's been minified.
So does it do the same thing with Dart? Do you have to like F11 like 80 times?
I'm not sure. I might just go to run the Dart.
To get something. That's
they run the post out.
Yeah. Yes. Unless they cheated. Okay. Any other questions? Well, I think this was a great event. And I can see I need to adjust for the time yet again, right? It seems like every time we grow, I didn't count on, whenever I did the time, I didn't count on the fact that we got more presenters this time because we have more teams using it. So I may have to keep extending it a little bit each time. So hopefully, I don't want it to turn into a full day event. I want to keep it at an afternoon, but we'll just see how that goes. So anyway, yes. Thanks.